Captions in English, please. So this is the first video on chapter 6. Chapter 6 is on chemical reactions. And so the first video will be an introduction to chemical reactions and the different types you can observe and evidence of chemical reactions. So how do we know a chemical reaction has occurred? So when we have physical changes, it involves a change in the physical properties of the substances, but not changes in the composition of the substance. So you start with a substance and you finish with the same substance. It just has changed from a solid to a liquid or a liquid to a gas or vice versa. So these are physical changes. Chemical changes involve a change in the fundamental component of the substance. So you're starting with some substances that we call reactant, and they will become new substances that we call product. So those chemical changes are often accompanied by physical changes, but not necessarily. So here there is a picture showing a space shuttle, starting to be launched. And so in the space shuttle's main engines, we have an hydrogen tank. And this is represented by the white molecules of, H2, two hydrogens bonded together. And then you have the oxygen molecules represented with the red molecules here, two oxygen atoms bonded together. And so they are separated, first they are separated, and then when you are launching the shuttle, they are put together and there is a spark to initiate the reaction, and that hydrogen and oxygen react violently together to form water molecule. And so what you see at the back of the space shuttle, all the white cloud are due to water in the steam, that comes out at the back of the shuttle. So this reaction is so violent and exothermic, it provides a lot of energy to be able to propulse the shuttle up in the air. So it's a very simple reaction, but it is so powerful, it has so much energy that you're able to send a shuttle in space. So other example of chemical reactions, you've probably all seen the chemical volcanoes, and these are examples of a gas evolution reaction. So in this reaction, you have baking soda, which is a sodium bicarbonate, and you make it react with vinegar. And in vinegar, the active ingredient is the acetic acid. And so together, sodium bicarbonate and acetic acid react to form carbon dioxide gas. So carbon dioxide is normally a gas at room temperature, so that's why it makes bubbles, all that foam with bubbles. Water and sodium acetate, so that's the product of this reaction. And so that's why you see all that foam. The newly formed carbon dioxide bubbles form out of the mixture, causing the eruption. And so reactions that occur in liquids and form a gas are called gas evolution reactions. So this is an example of a gas evolution reaction. Every day when you start a car, you're using combustion reactions. So in an automobile engine, the hydrocarbons like octane C8H18 from gasoline combined with oxygen from the air and react to form carbon dioxide and water. So you know that you put gasoline into the gas tank, gasoline is brought into your engine, it mixes with oxygen from the air and reacts again quite violently. releases a lot of energy that pushes on the piston, and that creates movement, and that will make your wheels turn. And so the product of that reactions are carbon dioxide and water, which are very stable molecules, and they are expulsed as gases because it's hot in the engine. And so combustion reactions are a subcategory of oxidation reduction reactions in which electrons are transferred from one substance to another. A laundry detergent, you are using laundry detergent to wash your clothes. And so laundry detergent works better than soap because it contains substances that soften hard water. So what is hard water? Hard water contains dissolved calcium and magnesium ions. And so these ions interfere with the action of soap by reacting with it to form a gray, slimy substance that we call curd or soap scum. And so you don't want that because if you have ever washed your clothes in ordinary soap, you may have noticed how the gray soap scum residue can stay on your clothes. So that's why the industry has developed laundry detergents to avoid that. And you see a picture here that shows the difference of what happens with, soap in pure water versus soap in hard water. So in pure water, the soap will form suds, which is what you want. But in the hard water, because there is the calcium and magnesium in the water, it will react to form a gray residue, which is a solid powder. The calcium and magnesium react with the ions from the soap and make that gray residue that will adhere to your clothes and will not make it really clean. And so laundry detergents contain substances such as sodium carbonate, Na2CO3, that remove calcium and magnesium ions from the water. So the dissolved carbonate ions, because when you have sodium carbonate, it's soluble in water, and so the carbonate ions are dissociated from the sodium ions, and the carbonate will react with calcium and magnesium ions in the hard water to form solid calcium carbonate and solid magnesium carbonate. And so that's the powder that you see, right? The gray scum here is made of those calcium carbonate and magnesium carbonate. And so these are solids, and they will settle to the bottom of the laundry mixture, resulting in the removal of the ions from the water. So laundry detergent contains substances that react with the ions in hard water to immobilize them. The goal is to put them away, move them away. And so reactions such as these that form solid substances in water are called precipitation reaction. So a precipitation reaction is when you're forming a solid powder when you are mixing two aqueous solution, two liquid substances. So let's go through some visual clues of a chemical reaction. So how do we know that we have a chemical reaction that has happened? And so visually, you can see some color changes. These are evidence that a chemical reaction has occurred. For example, the molecules embedded in the plastic of a child's temperature-sensitive spoon or a hypercolor t-shirt transform upon warming. And so the color of the spoon changes and the color of the t-shirt changes, and that tells you a chemical reaction happened there where the color is changing. So that's a visual cue or an evidence of a chemical reaction. Precipitation reactions are, easily noticeable as well, because you see the formation of a solid in a previously clear solution. So that's evidence that a chemical reaction has occurred. And here you see the example of a brown precipitate forming in the water. you see that, or in the aqueous solution, you see that the solution was clear like and colorless like water, and we are mixing another clear yellow solution. And so two solutions together are forming a solid here. The brown powder making volutes here is a solid, it's a powder. And so this is called a precipitation reaction, and brown powder there is called a precipitate. So you want to remember these words, precipitate, which is the solid forming in a precipitation reaction. Another visual clue is when you see gas forming, foam, a lot of tiny bubbles containing gas. And so the formation of a gas is also the evidence that you have a chemical reaction that occurred. Here there is the example of Diet Coke erupting out of the bottle when a Mentos is added to it. And so the formation of carbon dioxide, CO2, and CO2 is a gas at room temperature, but it was dissolved in the Coke. Carbon dioxide was pushed in under pressure inside the Coke. The Coke was sealed. And then when you're opening the Coke and dropping some Mentos there, you're giving a lot of surface area for the carbon dioxide to finally, get out of the solution, from a dissolved form into a gas again. And that's what will push it out, the gas. All this gas forming here, propels the soda out of the bottle, because it's a lot of tiny bubbles of carbon dioxide, and they are getting some soda with it around them, and then that's what you see here, all that foam. And finally, the last visual clues of chemical reactions are heat and light. These are easily seen as well. Heat, it's something you feel with the touch, or with your hand. So heat being given off or absorbed, or the emission of light are all evidence that a chemical reaction has occurred. For example, the picture in the upper right corner shows a Bunsen burner burning natural gas. And so when you're burning natural gas, you're producing both heat and light. You see the flame and you know that it's warm. And this is used to cook and warm the air inside the heating furnace in our houses. The cold pack here, it's a chemical cold pack. It becomes cold when the plastic barrier separating two substances is broken. So there is a barrier inside, and when you are breaking that barrier by moving the bag roughly, it breaks that barrier. The two substances get into contact and they react. And when they react, they absorb the heat. It's an endothermic reaction. So it's absorbing the heat from the surrounding, and that's why it becomes very cold. So it's not a production of heat here, it's absorption of heat. That is the proof that you have a chemical reaction happening. And the last example here of the glow stick, it produces light when the glass vial inside is broken. And again, chemicals that were separated are now allowed to mix, and they react together and produce a fluorescent molecule that gives off light naturally. So all of these are a sign that you have a chemical reaction happening.